It's really good to see you again. So today we're going to talk about 3 properties. The commutative property, commutative property, the associative property, or associative, but I say associative, who knows, the distributive property, and also the distributive property. So these 3. Okay, and these are properties of operations. Okay, so we would say, for instance, we'll focus on our 4 basic operations: addition, subtraction, multiplication, and division. And multiplication sometimes written with a dot, and division sometimes written with the fraction, but we won't worry about that. But you can generalize however you need to. Okay, but we'll focus on these 4 with arithmetic. So just numbers. And so these are properties of these operations. Okay? So today we'll play around with the definitions of these words and sort of start building a foundation, but they'll come in handy in algebra and moving forward. And you can also play around with it with logic problems, and they might show up on standardized tests, say the SAT, cough cough. Likely you won't see these words around much. I haven't really seen them used like commonly, but the ideas are there, so that's used all the time. So you might even make up your own operation, and I'll show you an example of that here as well. So don't worry if you fall asleep. This is meant to just be relaxing. And I won't get mad. You won't be missing class. You can just come back, pop back on if you're interested. But just relax. And who knows, if you just space out, maybe you'll just have these 3 words stuck in your head by the end of this video. And why not, right? Of all the things that you can get stuck in your head, this isn't so bad. At least I don't think so. So, for those of you who like lists, we'll go in this order. And so let's start with commutative. So, commutative. So remember that these properties apply to the operation itself, right? So for instance, I would say something like addition is commutative. So this is actually a true statement, and that's how I would say it. So the operation is what is commutative. And so what does commutative mean? Commutative means that you can switch the order of terms while applying whichever operation, and you'd get the same result. So for instance, if I take 2 numbers, let's say 2 and 3, 2 plus 3, because we're working with addition in this case, 2 plus 3 would be equal to 3 plus 2, if this is a true statement, which I just said it is, but let's confirm that. So 2 plus 3 is what? I won't judge you if you have to use your fingers. I'll just, plop this in here. 2 plus 3 is 5. And 3 plus 2 is also 5. And since these 2 results are equal, addition is commutative. Okay, commutative. This is only one example, so I can't necessarily just generalize that. But this kind of gives you an idea of what's happening. So I'm switching 2 terms. I'm switching the order of the terms while applying the, I should probably circle that too, while applying the operation that we're working with. And since we do get the same, so in general, a plus b equals b plus a. And since that is true, addition is commutative. Okay, so let's try subtraction. Is subtraction commutative? Well, with subtraction, we'd have to deal with some negative numbers sometimes, so that might be a problem if we pick two different numbers. So we'll say a and b are different. Does a minus b equal b minus a? And the answer there would be no, because let's take, for instance, 9 minus 5. Does that equal 5 minus 9? Well, 9 minus 5 is 4, right? So notice again, we're using the operation that we're checking. So we're taking two numbers and applying the operation. So we're checking subtraction. So 9 minus 5 is 4. And does 4 equal 5 minus 9, if you're already familiar with negative numbers, is negative 4. And since those two are not equal, sadly, subtraction is not commutative. If you're already familiar with algebra here, you can actually prove this to yourself by factoring out a negative from this and getting negative b plus a. And since I'm kind of fancy here, we literally just learned that addition is commutative. So this is negative. You can flip the order of these two. And in general, a minus b is not going to be equal to negative a minus b, right? Unless it's 0. But I don't think we can actually technically use this derivation because we are just now learning about commutative, and we technically factoring is kind of inverse of the distributive property. So that's not totally, proper, but you can just try out numbers, right? So you can show yourself that it's not always the case. And in general, if you can find one counterexample, which we just did, then the statement in general is not true. Okay? So anyway, that's neither here nor there. You can try the same thing with multiplication and division. Pick two numbers and use the operation that we're working with, and then switch the order and see if you get the same result. So I'll just jump ahead and let you know that multiplication is indeed commutative, but division is not. You can try that as a little thought experiment. But for multiplication, you can just say 2 times 3 equals 3 times 2. And that's true since this is 6 and this is 6. So that's pretty cool. At least I think so. So you can switch the order in general. So a times b and b times a. And that's also probably why if you've seen these two, if you've seen addition and multiplication, odds are you don't use the words very often. Like I said, the commutative or associative or distributive. You hear distributive quite a bit, but you'll see applications of it, because like in algebra, you might see someone go, okay, so we might get 2 plus x, and then they might just automatically say, oh, that's the same as x plus 2, and you might hear the phrase, order doesn't matter, or something like that. And this is why, because they're really talking about order for addition. The order of the terms don't matter because you get the same result. So that's really where it comes from. And same for multiplication. Like in algebra, you might see like, for whatever reason, you might need to do like xy equals yx, and you know that's true because when you smush variables together, you mean multiplication, and you can switch the order because multiplication is commutative. So we will be applying these properties in the future. So, okay, so addition and multiplication are commutative, and you can try this with any other operation should you choose. For instance, if I decide to say a heart b equals a minus b squared. This is a fun little problem. If you're interested, you can try it out. Let me know in the comments what you think. But if I were to say, is this commutative? Really, you would try, is heart commutative, right? Remember, it's operations. And you can see if you can try out if a heart b is the same as b heart a. And if you get the same thing, then it is commutative, and if you don't, then it's not. Okay? So this is a fun little thought experiment that sometimes shows up on tests and stuff, so just wanted to throw that out there for now. We might revisit it. Okay, so next is the associative property. Associative. And again, we're talking about operations. So I'll just rewrite our main for now. And for the associative properties, it's all about parentheses and regrouping. Okay. So what I mean by that is we need at least 3 terms. So for instance, let's see if addition is associative. Actually, I'll just tell you that it is. Sorry. At least I'm not spoiling like a TV show or something. Okay. I know. You were like really on the edge of your seat, right? Wondering if addition is associative. But really, what this is about is we can take 3 numbers. So let's just do 2, 3, and 4. Again, we're doing addition, but we're going to group the first 2 first, and then add 4, and see if that is equal to 2 plus 3 plus 4. So this is what I mean by parentheses. So we have 3 numbers here, 2, 3, and 4. But we're going to see if we add the first 2 numbers together first, and then add another number, if that's equal to just the first number plus the second and third numbers added first. So these parentheses force us to calculate what's inside of them first. This is like an order of operations issue. So the parentheses tell us do this first. So 2 plus 3 is 5. Then we have a plus 4. So we get 4. Wait, what? I was thinking a step ahead. 5 plus 4 is 9. On this side, we have to do the 3 plus 4 first because of the parentheses. So 3 plus 4 is 7. But then we still have this 2. So 2 plus 7 is 9. Okay? And so since we got the same result, addition is associative. That's the idea. Do you see what I mean by the regrouping? So if we want to generalize, we can say for addition, we do A plus B plus C equals, or I guess I should have written it this way, but it doesn't matter, a plus b plus c, okay? Or generally it's written that a plus b plus c equals a plus b plus c. Just because we're usually grouping the first two first, and then on the other side we're grouping the second two. So again, you can try this for each of these other three operations. But again, spoiler alert, multiplication is associative, but sadly, subtraction and division are not. So it's all about the grouping. So let's check multiplication. Let's just do an example just to keep practicing this pattern. So again, we're focusing on multiplication, but we're grouping. So we're going to do 2 times 3 first, and then times 4, and see if that is equal to 2 times 3 times 4. Okay, so again, the parentheses tells us we have to do that first. So 2 times 3 is 6. 2 times 3 is 6. Times 4 is 24. Okay. And there is a reason that, I don't know if you can even see this or if you're paying attention to the calculator, but there is a reason that I do 2 times 3 and then just delete and then do 6 times 4. It really emphasizes the point that I'm not just doing 2 times 3 times 4. And I don't really have parentheses on this basic calculator, so that's why I delete that on purpose, so that I'm not, I'm really emphasizing that I'm doing this first and then multiplying by the 4. Okay, so then 3 times 4 here, we're going to do that first. So that's 12. And then I'm going to do 2 times 12 is 24. And since those two are equal, multiplication is associative. So again, it's about the grouping. I'm going to first do the 2 and then multiply by this. And then I'm going to group the second 2. And notice that it's all multiplication here, right? Since we're checking if multiplication is associative. So we're just going to check one operation at a time. So this is plus and plus and plus and plus, times, right? So again, just addition and multiplication are associative. Man, I don't know which one sounds right. Let me know if you know. Not that typing it out would help. But if you can, let me know. So in this case, with algebra, when you're working with variables, you might see something like xy times z is x times y times z. And with variables, you just smush them together, so that's okay. So that would be like an application in algebra. I'm not sure if I think I did mention it before. With xy equals yx for commutative, this would be like the associative equivalent, okay? Okay, so then the last one is distributive. So far we have addition and multiplication are commutative, and addition and multiplication are associative, and subtraction and division are neither. And you can play around with whatever other operations you want. Now, distributive is a little more complicated to explain, I guess, but it's used a lot, and you've probably heard it if if you're in algebra, you will probably hear it, or you've already heard it, as like the actual word, the distributive property. And so this one involves multiple or two operations at once. So this is why it gets confusing a little bit. And usually you'll say, for instance, multiplication is distributive over distributive over addition, for instance. Okay. So that's how we would phrase that. So you have one operation being distributive over another operation. So we're using two at once. So what this means is, let's use our 2, 3, 4 again, but this means that I'm going to do 2 times because of this multiplication, and then do 3 plus 4. Okay, so this is the multiplication over, and then this is the addition. And we're going to have parentheses here. And so if you're in algebra, you might have seen like this happening, like these arrows and stuff like that. And what this means is we want to check if multiplication is distributive over addition, then I would do 2 times this stuff, and it should mean that this equals 2 times 3 plus 2 times 4. And I'm going to put the parentheses here for clarity's sake, but they're actually not necessary. Just due to order of operations, you always do multiplication first, but just for clarity's sake, I'm going to throw in the parentheses there to tell us that that's what we're supposed to do first. So what this means is I'm literally distributing this 2 times 3 here, doing that first, and then 2 times 4 here, and doing that first. And if these two give me the same result, then multiplication is distributive over addition. I'm distributing the multiplication over the addition. So notice, if you're a pattern person, this times is here and here. I'm multiplying it out, but I also have a plus and a plus here, so I'm going to keep that. Okay, so let's try this out and see if I get like the same results. So this tells me I have to do 3 plus 4 first. I'm doing that in parentheses. So 3 plus 4 is 7. And I'm going to do 2 times 7, which is 14. Okay, very good. Then I'm going to do this sign and do what's inside the parentheses first. So 2 times 3 is 6. By the way, I am not trying to get you really attached to your calculator. So don't get too dependent on this thing, but take your time. So then we have 6, and we have 8, and then we have a plus. So what's 6 plus 8? 14. So since these two are equal, that's an example of how multiplication is distributive over addition. And if you want to generalize that, we could say this. And, you know, if it's smushed together, we mean multiplication when we have variables again. So we can just write this as AB plus AC. Okay? And so this one can be kind of tricky to really visualize what's going on, because, you know, then you'd have to do is multiplication distributive over subtraction, and it actually is. So finally subtraction can come into play. And you can try, like, you have to do multiple operations, but either case you're just going to do like whatever your operation is. So we could do something a little bit wonky, like is division distributive over, technically we could say this is a little weird, but division is distributive, or is it distributive over multiplication, question mark. And so just to show you another example of this pattern, is this true? And it is not true, but if it were to be true, we could say something like, is 6 divided by 2 times 3. Okay, so here's the division over the multiplication. If this really were true, does this equal 6 divided by 2, like distributing this? And so then keeping the times, 6 divided by 3. And that answer should be no. Just really quickly here, you could do this stuff in the parentheses first. So 6 divided by 6 is 1. 6 divided by 2 is 3. Times 6 divided by 3 is 2. So 3 times 2 is 6, which is not 1. Yeah, and so that's it. So it's not, so division is not distributive over multiplication, but that's the general idea for two operations. So really it's like combining this together first and seeing if you can distribute that first part over the second operation. So you can play around with this. Generally, we use multiplication as distributive over addition, and multiplication is distributive over subtraction. Let me know if you have any questions. Thank you for joining me. I'll see you